Welcome all. In this lecture, we are going to discuss about analysis of waveguide general approach. So, for the analysis of waveguide, let us have a look at some arbitrary shaped waveguide which is being attached with the conducting pipe. Now, if we talk about the direction of x, y and z axis, then we have vertically oriented x-axis and also we have horizontally oriented z-axis. Now this y-axis which is being perpendicular to both this x and z-axis. So this is our y-axis. Let me write it. We have arbitrary shaped waveguide Now, in this waveguide, the EM energy can flow along the axis of this pipe. And consider this is the z direction as a longitudinal direction. So this is longitudinal direction. And there is any direction which is being perpendicular to this longitudinal direction is considered as transverse direction. So this is transverse direction because it is being perpendicular to longitudinal direction. Now let us discuss the electric field and the magnetic field which is being given as First of all, the electric field in terms of the transverse component is Et plus the longitudinal component, that is Ez into z gap. This is the vector quantity and it is a scalar quantity, and this represents the transverse component and it represents the longitudinal component of an electric field. This is our equation number 1. If we talk about the magnetic field, then the magnetic field that is being equals to H transverse plus Hz into z cap. This is also a transverse component and a vector quantity, and it is a scalar quantity which is a longitudinal component of magnetic field. This is equation number 2. Now, if we define the transverse component of the electric field and the magnetic field, then its representative will become here E transverse, that is being equals to Ex into x cap plus Ey into y cap. Similarly, the transverse component of magnetic field will be represented as Hx into x cap plus Hy y cap. If we define the operator del, then the del operator will be del in terms of the del transverse plus del over del z of z cap. So this is the representation for del operator, and here the del transverse is given as del transverse, which is being equals to del over del x into x cap plus del over del y into y cap. This is our equation number 3. So these are our 3 equations, that is equation for magnetic field, electric field and del. Now moving on to the step number 2, that is we know that from the Maxwell's equation which is given as del cross E equals to minus j omega mu h. This is the expression for Maxwell's equation. And if we substitute the value of electric field, magnetic field and the del, then we get, first of all we will write the value of del from equation number 3, then del T plus del over del Z of Z cap cross, we will write the equation of first, that is electric field, Et plus Ez Z cap, which is being equals to minus of j omega mu, and the value of magnetic field is H transverse plus Hz into Z cap. These equations we get from the equation 1, 2 and 3 after substitution. Now on opening the bracket we get del transverse cross E transverse plus del transverse cross Ez Z cap plus del over del Z of Z cap cross E transverse plus del over del Z of Z cap cross Ez Z cap equals to minus of j omega mu H transverse plus Hz Z cap. So these all terms we get after cross multiplication, and we know that the cross product of the Z will result into transverse component. So here is the cross product with Z cap, and here also the cross product with Z cap, and this is also a Z cap. So we can say that this is the transverse component, this is also a transverse component, and rest all are the longitudinal component. So this is the longitudinal component, and since here is an identity which is made because Z cap is being cross product with this Z cap, so it is nothing but equals to 0 only. Now comparing the transverse and the longitudinal component, we get, on comparing the transverse component, we get in the RHS, here is the H transverse which is serving as a transverse component. So minus j omega mu H transverse, which is being equals to this transverse component, that is del T cross Ez Z cap plus del over del Z Z cap cross E transverse. On solving and taking this minus j omega mu in the RHS, it will become H transverse, which is being equals to minus of 1 over j omega mu del transverse cross Ez of Z cap plus del over del Z of Z cap cross E transverse. This is our equation number 4th, which is the expression for H transverse. So this is the expression for H transverse. And moving on to the step number 3, that is according to the Maxwell's equation, we can also say that del cross H equals to j omega epsilon into E. Since we have evaluated this expression from del cross E equals to minus j omega mu H, and here is another expression for the magnetic field, that is del cross H equals to j omega epsilon into E. So similarly, from this expression we can find out the value of ET. So the value of ET is nothing but j omega, and in place of this mu we will write epsilon, because here is the epsilon, and in the expression del cross E equals to minus j omega mu H, there is a negative sign, and here is no negative sign, so we will convert this term into positive and multiply with del T cross product with, in place of Ez we will write H of Z into Z cap plus del over del Z of Z cap, in multiplication and cross product with, in place of Et we will write here H of T. So this is the modified equation for E transverse. This is our equation number 5. Now here is the term, that is H transverse, and we also have a value for the H transverse from the equation number 4. So on substituting the value of H transverse in equation number 5, on substituting the value of H transverse in equation number 5, we get the expression for E transverse as 1 over j omega epsilon del T cross Hz of Z cap plus del over del Z of Z cap cross, in place of Ht we will write this value, that is minus of j omega mu del T cross Ez Z cap plus del over del Z of Z cap cross Et. So this is the expression. On simplifying this expression for E transverse, we get the modified value as omega epsilon mu into Et minus del over del Z into Z cap cross del over del Z into Z cap cross E transverse, that is being equals to minus j omega mu del transverse into Hz of Z cap plus del over del Z of Z cap, which is in cross product with del transverse in cross product with Ez Z cap. Now here are the triple cross product, and here also is the triple cross product. So by the vector triple product identity, we can say that A vector cross B vector cross C vector can also be written as A vector dot C vector in multiplication with B vector minus A vector dot B vector in multiplication with C vector. This is the vector identity. So we will apply this vector identity on this two triple product separately. So this term, that is del over del Z of Z cap cross del over del z of z cap cross E transverse by the help of this vector triple product identity can be written as del over del z in multiplication with del over del z of z cap dot E transverse into z cap minus del over del z of z cap dot del over del z of z cap in multiplication with Et. Now we can say that here is a dot product between z and z, which will become identity or 0. So it will become 0 only, and the final result of this expression will become minus del 2 over del z square E transverse. So this is the result of this 3 product. Similarly, by the vector triple product identity, we will solve this expression also. So by the vector triple product, we can write it as del t, which is in multiplication with del over del z of z cap multiplication with Ez z cap minus del over del z of z cap and dot product with del t Ez z cap. So we can say that here is the z cap and here is also z cap, so this will result into 0. So the final value is del t into del over del z of E of z. Why we get this term as a 0? Because here is a dot product between this del and this z, and the dot product of del and z will result into 0, and here the z and the z, which is in being multiplication, and will result into identity, that is nothing but 1. So we get inside the bracket that is del over del z into E of z. On substituting the value of this expression and the previous expression that we evaluated, the final expression will become omega square mu epsilon Et plus del 2 over del z square Et, that is equals to minus of j omega mu del of transverse cross product with hz into z cap, and in addition with del transverse, and we will write this term that is del over del z of E of z. Now for the travelling wave in z direction, we can say that this del over del z will become minus gamma, and this del 2 over del z square will be replaced with gamma square. So on replacing del over del z and del 2 over del z square with gamma and gamma square, we get omega square mu epsilon plus gamma square E transverse equals to minus j omega mu into del transverse in cross product with hz into z cap minus of gamma del t Ez. Now let's assume that this expression, that is omega square mu epsilon plus gamma square, is equals to small h square. So the value of Et will become E transverse, which is in equals to minus of j omega mu over small h square into del transverse in cross product with hz of z cap minus of gamma over small h square del transverse into E of z. This expression will come into the RHS and in the denominator. Similarly, from this electric field expression, we can also evaluate the magnetic field expression. So, H transverse will also become j omega epsilon over small h square into del t in cross product with E of z, z cap minus of gamma over h square del t into h of z. So we simply replace E in place of h in this expression, and it is a modified expression for magnetic field. Now let us come to the conclusion part. So after the analysis of the waveguide, we got some conclusions. According to the conclusion number 1, both the electric and the magnetic field component in the z direction cannot be 0 except small h is equals to 0. So both the Ez and the Hz component cannot be 0 except when small h is equals to 0 only. Moving on to the second conclusion, that is when small h value is equals to 0, then Ez and Hz component have the value equals to 0. So this is the reverse or the vice versa case of first conclusion. Moving on to the conclusion number 3. So according to the conclusion number 3, if the Ez value is equals to 0 and the Hz value is can't equals to 0, we will get TE wave. And if we get Ez can't be equals to 0 and the value of Hz is equals to 0, then we get TM wave. And when the value of Ez is equals to 0 and also the value of Hz is equals to 0, then we will get TEM wave. So these are the 3 expressions or the conclusion that we get after the analysis of waveguide. If you like my videos, then do subscribe my channel and please hit the like button. Thank you.